Here, in example 33, we want to show that secant square of x minus 1 divided by secant square of x is equivalent to sine square of x. We want to show that the big expression or the complex expression, all that, is equal to sine square of x. The number one method to show in trigonometry that one expression is equal to another is to express everything in terms of sine and cosine. So we're going to choose the complicated expression. We're going to rewrite in terms of sine and cosine. Before we start doing the problem, we need to remember some basic trig identities. We need to remember that secant of x is equal to 1 over cosine of x, which means that secant square of x is equals to 1 over cosine square of x. Now that we remember these identities, let's start with the problem. Let's try to rewrite everything in terms of sine and cosine. So we see that we're going to choose the most complicated expression, modify it, and make it equal to sine square of x. So we have the following: 1 over cosine square of x minus 1 divided by 1 over cosine square of x. In order to get rid of a denominator which is written as a fraction, we can multiply by the reciprocal. So we have 1 over cosine square of x minus 1 times the reciprocal denominator, which is going to be cosine square divided by 1. So now we distribute. So now we have cosine square of x divided by cosine square of x minus cosine square of x, which we have as 1 minus cosine square of x. Now another identity I would like to point out is the Pythagorean identity, which says that sine square plus cosine square is equal to 1. So we see that we can modify this expression by subtracting cosine to both sides. So now we have the sine square of x is equal to 1 minus cosine square of x, which is exactly what we have in our problem. 1 cosine square of x, according to the third trigonometric identity, we see that it's equal to just sine of x square. So we have that 1 minus cosine square of x is equal to sine square of x. So now, in example 34, we want to show algebraically that for the exact value of x, this is equal. Now, what we want to show is how can we modify this equation and find the value of x, basically solve for x. So now, when we're dealing with fractions, you want to find the lowest common denominator, which in this case is 4x. 4x can be divided by 2. 4x can be divided by x. 4x can be divided by 4. So now, what we want to do is going to get the original and multiply by the LCD. So we have 5x divided by 2 equals 1 over x plus x divided by 4. We said we're going to multiply by the LCD, which is 4x this way, we're going to multiply 4x to both sides. So now, if we distribute, we are going to have 10x squared equals to 4 plus x squared. We got 10x squared because this 2 cancels out with this 2, and becomes a 2. So 2x times 5x is 10x squared. If we distribute here, this x is going to cancel out with this x, and we're going to get that 4. And this 4 is going to cancel out with this 4, and we're going to get this x squared. So now we want to solve for the following. So let's say that equal to 0. Cancel, cancel. So now we have the following. We have 9x squared minus 4 is equal to 0. Now, we notice that on the left side, we have a difference of squares where 9x squared can be expressed as 3x times 3x, and 4 can be expressed as 2 times 2. So that means that we can factor out the left side as 3 of x plus 2 times 3 of x minus 2. Whenever you have two expressions multiply, they're equal to 0, you set each expression equal to 0. So now we have 3x plus 2 equal to 0, and 3x minus 2 equal to 0. We solve each equation individually, so minus 2 here. So we have 3 of x equals to negative 2. Divided by 3, divided by 3. So we see that one of our equations equals to negative 2, negative 2/3. We solve the other equation as well. So we have 3x equals to 2, division of 3, division of 3. So we see that x is equal to 2/3. So that means our solutions are x equals to plus or minus 2/3. So now we look at example 35. We see that we want to simplify the following sigma notation. Remember that sigma notation means to sum up, and all we're doing is we're going to substitute these values to a. We're going to substitute a's, and for every substitution, we're going to add it up from 1 all the way to 4. So we're going to have the following: x minus the first substitution, which is 1, square plus x minus the second substitution, which is 2, square plus x minus the third substitution, which is 3, square plus x minus and the fourth substitution, which is 4, square of x. Now we simplify. So now we have that x minus 1 plus x minus 4 plus x minus 9 plus x minus 16. So now we can combine like terms, x plus x plus x plus x. That gives us 4x, negative 1 plus negative 4 plus negative 9 plus negative 16. That gives us minus 30, which is our final answer.